Here are the lecture notes for Chapter 18. And there will be only one section for Chapter 18. First, I want to remind you, if you have 41 questions on your assignment, we should only have 40. So I do not want you to do a problem with number 26. It's about a lady with a patio, and she wants to find the area. So please do not do number 26 if you have 41 questions on your assignment. We should only have 40. This chapter is a little bit on geometry, and they want you to name this line in 3 different ways. Well, a line is a number with 2 arrows, one in each direction. So if we have HJ with a line like this, JK is another way you can write it, and HK is the other way to write it. Arrows in both directions. Now this would not be counted as one of your 3. If you just switch these around, that would not be one of the 3. Do this one, and this one. Arrow in both directions. Then they want 2 line segments with the endpoints JK. Now endpoints and line segments have 2, you just want the area from here to here, or in this case, you can write it like this. And those are line segments. It starts at J, ends at K. In this one here, it starts at K and ends at J. So it's the same length. Line segments have endpoints. Lines do not. They continue to go on forever and ever and ever. The next thing they want you to do is they want you to name this angle using letters in 2 different ways. Name these angles using letters in 2 different ways. Angle BCA, or you can say angle ACB. It has to have, the C has to be in the middle because that's called the vertex. The C is called the vertex. That's why we have it in the middle. Then you want to have this down in your notes someplace. When you go to take your test and do your homework, you need to know these things. A right angle is 90 degrees. A right angle is 90 degrees. Straight line is 180 degrees. Acute angle less than 90 degrees. Obtuse angle greater than 90 degrees. So if it's exactly 90 degrees, that's a right angle. 180, straight line, like this. Acute, less than 90. Obtuse, greater than 90. So those terms are going to be very, very important. So make sure you have those down somewhere. Complementary angles, they're angles that total to be 90 degrees. Complementary would be 90 degrees. So if they ask you, what is the complementary angle of 47 degrees? You would going to say 49. Supplementary, 180 degrees. The total of the angles equal 180 degrees. Again, these 2 words are very important that you know. Complementary, 90 degrees. Supplementary, 180 degrees. This diagram, you have line M and line N, and they're parallel. These 2 lines make it parallel. The P is a transversal which cuts both line M and N. And they're saying that there's no right angles. No right angles. So, angle A and angle D have the same measurement. Angle E and angle B have the same measurement. Angle E and angle H have the same measurement. Angle G and angle F have the same measurements. They are equal to each other. Angle C and angle E make up 180 degrees. Angle A and angle G make up 180 degrees. And same way on the other side. D and F equal 180, B and H equal 180. Angle A and angle C equal 180 degrees, as would be B and D, F and H, G and E, all make up 180 degrees. E and F equal 180 degrees. G and H equal 180 degrees. Anything that would make up a straight line makes up 180 degrees. Here are some equations that you want to write down and have it close at hand. Perimeter is distance around. So when they ask you for a perimeter of anything, all you do is add all the sides, whether it's 5 sides, 6 sides, 10 sides, 3 sides. You just add the distance, so you add it up. So all you do to find perimeter is just add. Now, of these, you want to make sure that you have this down. Area of a parallelogram, base times height. The height is this part that makes a 90-degree angles with your base. Not out here, that's not the height. The height makes a 90-degree angle with your base. So the area of a parallelogram is base times height. The area of a triangle is 1/2 base times height. Again, your height is anything that makes a 90-degree angle with your base. Trapezoid, base 1 plus base 2 times your height, and take it times 1/2, or divide by 2, whatever your case may be. You're adding base 1, base 2, take it times the height, again this right here, not out here, not this stuff, 90 degrees, and divide by 2. That's the area of a trapezoid. Area of a rectangle and a square, we know, length times width is all it is, length times width. They'll give you an area of a square is side squared, which is the same thing as length times width. Then you'll need to know the area of a circle, and they will want you to use your pi button, not 3.14. So the area of a circle is pi r squared. The circumference of a circle is 2 pi r. Again, use the pi button. Do not use 3.14. Just wanted you to remember, if the diameter is 10, don't forget the radius would be 5. The radius is half the diameter. If the diameter is 15, the radius would be 7.5. One other thing that I want you to have close at hand, maybe you have forgotten, is this. 1 square foot equals 144 square inches. You will need that in some of your problems. 1 square yard equals 9 square feet. Make sure you have this somewhere in your notes. 1 square foot equals 144 square inches. 1 square yard equals 9 square feet. The area of a circle is pi r squared. The circumference, which is the distance around, is 2 pi r. If they give you the diameter, all you have to do is divide by 2 to find the radius. Now I'm going to show you how to go from degrees to radians. If you have the TI-30XA calculator, it's very simple. Type in 46, pick your second function key, your DRG button. That's all you do. Type in 46, second function, DRG, 0.0 or 0.80285, etc. If you want to make sure now when you go to do your calculator, all you do is shut it off, turn it back on, and that gets you out of your radian mode. So 46 degrees, or just type in 46, second function, your DRG button, which is right next to the second function key, way at the upper left-hand corner, and that gives you radians. Again, to get out of radians, just shut your calculator off and turn it back on. Now, if you don't have that type of calculator, this is what you need to do. You need to type in 46 degrees times pi. Divide by 180. And that will give you your radians also. 46 degrees times pi, divide by 180. That will also give you your radians. Then just a couple other things here. Volume, we know, is length times width times height. The cylinder, like the volume of a tin can, the bottom of a tin can is your circle, so it's pi r squared, and then you've got your height. Pi r squared times height. Now the volume of a cone, they give you this, but this is a better equation for you. 1/3. Now the volume of a cone is the area of a circle. Pi r squared times your height. I would use this equation. It would be much easier for you. The volume of a cone is 1/3 pi r squared times h. The volume of a pyramid is 1/3 length times width times height. Again, that would be much easier for you to remember. One-third length times width times height. And then the volume of a sphere, which is a basketball, 4/3 times pi r cubed. 4/3 times pi r cubed. And again, all these equations you'll want those right close at hand when you go to do your assignment and your test. These equations are very important. Again, use these equations for a cone and a pyramid. That takes you the end of chapter 18, one section. Again, please do not do number 26. I think the question is a lady in a patio that wants to cover a patio, and that is a total different triangle that we want to use.